Here's another example of computing a definite integral. Here if f of x is equal to the opposite of the square root of 16 minus x squared. All right, we want to find the integral from 0 to 4 of f of x with respect to x. That is, find the integral from 0 to 4 of negative the square root of 16 minus x squared dx. And so let's take a look at how we would go about doing that. First of all, let's examine, be sure we know what this curve is. So we have y is equal to negative square root of 16 minus x squared. If I square both sides, y squared will be equal to, squaring this, I'll get 16 minus x squared. Adding x squared to both sides, I'd have x squared plus y squared is equal to 16. This is a circle with radius 4 centered at the origin. So we have a circle with radius 4 centered at the origin. And so what we have here is we have a quarter of this circle, and we're below the x-axis. So this integral from 0 to 4 of negative the square root of 16 minus x squared with respect to x is going to be this area. But because it's below the x-axis, remember that the definite integral is going to treat it as a negative value. So let's see. So let's think about this. Remember that the area of a circle is pi r squared, but in this case, we only want a fourth of it. We don't want the whole thing, just 1/4 of it. So it'd be pi r squared divided by 4, and the radius is 4. So it would be pi times 4 squared, squared divided by 4, and that would be just 4 pi. So the area enclosed here is 4 pi, but since it's below the x-axis, the definite integral will treat it as a negative area. So it'll be negative 4 pi will be the value of this. Now this integral, all right, would be a tough one to calculate, even with the special techniques that we'll learn in section 5-6. This would be a very, very difficult integral to calculate. And so lots of times you would just calculate it geometrically, as we have done here. You'll learn a technique to do it in calculus 2.